All right, hey Jake, this is the backside of the Chapter 3 review for limits, for Calc. And we're going to do this backside. It doesn't go, it doesn't take very long. But then I have some review problems that I must have put up here last year when we did some whiteboards. So I was going to maybe go through those. So if you feel like you need the extra practice, go for it and watch that. But here's the deal. All right, so number 9. Determine whether 1 over x minus 2 squared approaches infinity or negative infinity as it approaches 2. So we're looking at basically what it's saying, the limit as x approaches 2 of this guy. 1 over x minus 2 squared. I cannot plug that in, correct?
Graph it.
Okay, so the graph, I know what the graph of that looks like. The parent function of that guy is 1 over x squared, which looks like a volcano, right? But it's shifted 2 units to the right, okay?
Which doesn't make any deal.
1, 2, which just does this, and it does a volcano. So as it approaches 2, is it approaching infinity or negative infinity?
Infinity.
It's going up. It's approaching infinity, okay?
Is it 2 minus or 2 plus? Are we
It's 2 from both sides, so just infinity, both sides.
Oh, because it's both at the same time.
Yeah, it's both at the same time. Oh, as it approaches 2 from the left and from the right. So yeah,
So
it's
2
infinity.
plus.
It's infinity.
Because
It's infinity for each one.
It has our steps and our graphs and yeah.
Please.
Memorize it.
Please.
That's not a long list.
No, but
It's
it
not
is
a long
really
list.
helpful.
No,
Yeah,
no,
please.
memorize it.
No.
All right, find the vertical asymptotes
Okay.
of the graph. Okay.
Plug it equal to 0 at the bottom.
Bottom equal to 0. So
Is
we've
that
got
a 2?
this guy, x. What is it?
Plus 3x minus 2.
Plus 3 minus 2. Are any of those holes?
Nope.
So x equals, my bars are at x equals negative 3 and x equals
I know I'm stupid, but
positive 2.
it would have been a whole.
It would have been a hole if
If
let's
it was-
say this top was x plus 3, then negative 3 would have been a hole.
How do you know the difference between that and vol?
A hole cancels out.
A hole cancels out, a bod is not. So it's both where you set the denominator equal to 0, but a hole is what cancels at the top and the bottom.
Leave the hole on the top.
The hole would have been that, but the vol, it would have been, what would have been a vol? What's an
So
example
if
of a vol?
this was the problem, right here, and it wasn't x squared on the top and it was x plus 3, then the x plus 3 cancels. So this was actually a hole and not a va. This is still a va.
Okay.
So it starts as a va first, but if it cancels,
so
it's
these
a
are
hole.
both vos on here?
They are both vas because nothing cancels.
Of course, yeah.
Okay?
Yeah.
Good? Happy with that? All right. Here you go. Determine whether it has a vertical asymptote or a removable discontinuity.
Which is just a hole.
Which is just a hole. A removable discontinuity is a hole because it removes out, right? Like it pulls out.
This is
So
why we need to
at
use
negative 3.
Yeah,
Okay?
but it has a removable
So I can't
discontinuity.
plug negative 3 in. That would be where we would find the limit, but we need to decide is it a hole or a vase. So x squared minus 9. Hey, I'm recording for you.
The saturations are good.
X plus 3, x minus 3 is what the top is over x plus 3. So that means that if I would have set the bottom equal to 0, it would have been x equals negative 3. But it's canceling out, so that is not a va. It's a hole or a removable discontinuity, which is a hole. It removes out. It's a removable discontinuity, so it removes out. Got it?
Kind of doesn't work.
Okay.
Work in my brain, but
Beautiful.
okay, keep going.
Okay.
These ones just plugged, right?
Are you gonna live?
All right, this one. What about the limit as x goes to 6 of that thing?
16.
What is it?
16.
16. How'd you get 16?
I just plugged it in.
Plugged it in. This one's a plug-in. All right, 13. Can you plug it in?
No.
No. What are you gonna do?
Break down the top.
Break down the top.
Yeah.
I'm gonna call them x's. X plus 3 and x minus 3, and x minus 3 on the bottom
So
cancels.
that means x minus 3 is a whole.
X minus 3 is a whole, which is actually x equals 3, right, Emma?
So
Emma?
is that,
Yeah.
do we write that
Okay.
as a limit or
So
do we
that's
just
gone.
write-
No. Now you're
Oh.
evaluating the limit.
6.
You still have to do the limit part, right? So this then transforms into the limit as x goes to 3 of just x plus 3,
Okay.
right? Like this reduced to become x plus 3. So now the answer is 6 because now you plug it in, right? You get it to the point where you can plug it in, right?
Oh,
Do you want me to keep recording, Jake? No.
I don't like 14.
I'm still recording for you. What?
No, that's all right.
You want me to stop it?